Dear students, welcome to Impulse Masterclasses, a program designed for 10th class students. I'm Yohan, Zoology lecturer, having 27 years of experience. I'm one of the Telugu Academy textbook authors. At present, I'm working in Impulse Institutions, Hyderabad. Today, we are going to discuss about the mechanism of breathing. Let's have a look at this question. In humans, breathing is A. Positive pressure breathing, B. Negative pressure breathing. In order to know the answer for this question, we need to understand the following concepts: lungs, thoracic cavity, and muscles involved in breathing. Let's understand the structure of lungs first. In terrestrial animals, including human beings, lungs are the respiratory organs. In human beings, a pair of lungs are found in thoracic region, and the air pipe, that is trachea, that enter the thoracic region divides into two primary bronchi. Inside the lungs, they divide into secondary, tertiary bronchi, primary, secondary, tertiary, and terminal bronchioles, and finally open into sacs called alveolar sacs lined by alveoli. Here I'll tell you one interesting fact. The total length of air passages in both the lungs in humans constitute around 2,400 kilometers. And one more important thing, the total alveoli in both lungs together constitute 500 to 600 millions, whose surface area is around 80 to 90 square meters. That is around the size of tennis court. Each lung is surrounded by double layered pleura. Between the two pleura, we can find fluid called pleural fluid that acts as a lubricant, reduces the friction between two lungs. Here we have to remember two important things. The air passage from trachea to initial bronchioles are lined by C-shaped cartilaginous rings. They prevent collapse of respiratory passage. And one very important thing, alveoli are the sites where the actual exchange of gases takes place. Now let's understand the structure of thoracic cavity. You know that thoracic cavity is an airtight chamber whose ventral surface is formed by sternum, dorsal surface is formed by vertebral column, lateral surface is formed by ribs, and posterior dome-shaped diaphragm. This is a complete airtight chamber, play an important role in movement of lungs which help in breathing. Diaphragm is a muscular partition that separates the thoracic cavity from abdominal cavity. Remember, this is the characteristic feature of mammals. Now let's see the muscles involved in breathing. The very important muscles involved in the mechanism of breathing are: number one, diaphragm muscles. They're also called as phrenic or radial muscles. Number two, intercostal muscles. As they are found between the ribs, the name given as intercostal muscles. Actually, there are two types of muscles: internal intercostal and external intercostal muscles. So these are the muscles who play an important role in breathing. Now let us see the mechanism of breathing. You know, breathing involves inspiration and expiration. Inspiration is intake of air. Expulsion of air is nothing but expiration. Now this is the normal setup of thoracic cavity in relaxed state. You know the boundaries are sternum, diaphragm, vertebral column, and laterally ribs. Now during inspiration, what happens we'll see. Due to the contraction of diaphragm muscles, the diaphragm becomes flat. So the thoracic cavity increases anteroposteriorly. At the same time, external intercostal muscles contract. So the thoracic cavity increases dorsoventrally. So here overall thoracic cavity increases and the space increases, and this can pull the lungs away. So the lung cavity increases. That creates negative pressure when compared to atmosphere. This is called negative intrapulmonary pressure. And this helps in drawing the air from atmosphere to lungs. This is nothing but inspiration. As you know that air always move from high pressure to low pressure. As the cavity increases, it creates negative intrapulmonary pressure, so the air can easily enter the lungs. Now during expiration, what happens? The diaphragm muscles relax, so it again come back to dome shape. Thoracic cavity decreases anteroposteriorly. External intercostal muscles relax, so the thoracic cavity again come back to normal position dorsoventrally. So overall, thoracic cavity decreases. That puts pressure over the lungs. So that creates a positive intrapulmonary pressure when compared to atmospheric pressure. So the air can push out. Here you need to remember one very important key point. Lungs by themselves, they cannot expand or contract, and their expansion and contraction is mainly brought by the expansion and contraction of thoracic cavity. Now let's see the difference between negative pressure breathing and positive pressure breathing. During inspiration, when the lung pressure is lesser than the atmospheric pressure, the air can easily pass into the lung. This is negative pressure breathing. In the same way, when the lung pressure is greater than or equal to atmospheric pressure, a special mechanism is involved to push the air into the lungs. This is positive pressure breathing. Let's get back to the initial question where I asked the breathing in human beings is positive pressure breathing, negative pressure breathing. So here the answer is negative pressure breathing. So the option is B. Hope you enjoyed this masterclass. See you in the next class. Thank you.